Right, okay, we're going to look at moments. Moments is a tough little topic because there's some conceptual issues there, and we're going to go through it over the next couple of videos to kind of bring out the key points. There's some examples on the channel of some moment questions, a qualitative one from specimen paper. Do have a look at that, because that will help out with this as well. Okay, well, first of all, we need to talk about equilibrium. And what it is. So equilibrium is the process by which everything is balanced out. So in order to get something balanced, the forces need to be balanced as well, as you would expect. And where we looked at in the forces video, we looked at balanced forces allowing things to be stationary. So in this case, balanced forces mean things are stationary. So we can say that the net force for equilibrium must equal 0. The second thing that we get onto, which is really important, is net moment is 0. So the net moment is 0 and the net force is 0. Now the net force being 0, hopefully you can understand that without too much extra explanation from me. But the net moment, well, we need to know what a moment is for something to be in equilibrium. So let's have a look at what a moment is. So it starts out with something that you could try at home with a sibling or someone of similar size or much weaker or much stronger than you. It doesn't really matter. What you'll do is buy a door. So this is a door, top-down view of a door. One of you will be trying to shut the door by pushing it or pulling it open even. And the others of you will be trying to shut it. Now, one of you will be close to the hinge and the other of you will be really, really far away. Now, what we're looking at here as a situation is, if, for example, you put the strong person, really strong person here, and a really weak person, works great if you've got a little brother or sister, or mum and dad, who's much weaker or stronger than you, depending on what your family's like. You can try this at home. Obviously, just bear in mind any health and safety issues. Don't get your fingers trapped in the doors and whatnot. Just be careful. Don't overexert yourself as well. But what you'll notice is that no matter how strong this person is, this person will always win this fight. Why is that? Well, it's because their moment is greater. What is a moment? Well, moments are calculated by force times the perpendicular distance to the pivot. Now that perpendicular distance is important, and in one of the later videos we'll talk more about situations where that's really, really important. But we'll focus on just the idea for the moment that it's the force times the perpendicular distance from the pivot. So i.e. at right angles. So here is our pivot. And in this case, we can say that this person, we could say they have a force of 100 newtons, for example, and they act at a distance of 1 centimetre from the pivot. And then we've got this person over here, which acts at a distance of, let's say, a metre, so it's 100 centimetres. And they could be really, really weak. They could be 10 times weaker. So we'll just say they're half as strong, 50 newtons. Okay, so this person is pulling with 50 newtons. This person is pushing with 100. This person wins the pull because, quite simply, their moment is greater. Now let's look at the calculations for these moments. So we've got 100 times 1, force times the distance, which is 100. And then we've got 50 times 100, so we've got 50 times 100, so that gives us 5,000. So again, that's the force times the distance. So numerically you can see that this moment is quite significantly bigger, and so that's why the person wins. It's not to do with their force, it's all to do with the idea of the line of action of the force from the pivot. What's the unit for a moment? Well, in this case it will be Newton centimetres, because we're doing force, which is in newtons, distance, which is in centimetres. The same for this one, Newton centimetres. And as you can imagine, you go anything from Newton millimeters to Newton meters to Newton kilometers if you really, really wanted to. But in this case, we're going for centimeters. Now, most cases will be in meters, but that's not to say you don't need to be able to recognize these. So that's a basic understanding of this. But this is not in equilibrium. Okay, this is not in equilibrium. The next video I will show you will look at some more difficult situations about how we can use moments and moment calculations in order to work out maybe some unknowns. So the force times the distance here is 100, force times the distance is 5,000. This person wins because their moment is greater, the distance from the pivot.